Hello everyone, welcome back. So today we'll be doing the Minesweeper game. So let me go on a whiteboard and let me explain to you what I was thinking of doing for this. Let me take a pen. All right, awesome. Great. So we'll have a concept of a board, right? So let's take this one, for example. So the beginner level for Minesweeper is an 8 by 8 grid, right? So we'll need 8 column, 8 rows. I'll just do a couple right now. It doesn't matter that it's not 8. It's just for the concepts. Anyway, after that it can apply to pretty much any size that you want. I'm just stating that the regular Minesweeper beginner level is 8 by 8 with 10 mines, right? So there you go. There. Okay. Great. So we have our grid. It doesn't matter the dimension. It's definitely, well, no, it's not 8 by 8. I think it's 9 by something. Anyway, so 8 by 8 for the grid and 10 mines. So, um, so basically what we need to do with this grid is we need to initialize the 10 mines first. So we randomly assign spots on the grid where there's mines. So let's say all of the x's are mines, right? Maybe there's 2 close together, right? So all of those spaces are mines, for example. We then need to go through every single cell in the grid and check how many neighboring mines there is, right? So in this case, this one would only have 1, 1, 1, 1, 1, 1, 1, 1. Yeah, so that's what we need to do. This one 0, 0, and one neighboring cell is one of the 8 surrounding cells, right? So this would also be 1s. This would be 0, 0, 1, 1. Oh, this, never mind, it's not 1, it's 2, right? It's adjacent to 2 mines. This, never mind, it's also 2, because there's 2 adjacent 1. Here it's 1, 1, 1, 1, no, it's 2, right? 2 again, here it's 1. What else? Here it's 0, 0, 0, 1, 1, 1, 1, 1, 2, right? 2 again, 1. Here we have 2, right? 1, 2, 1, 1, 1, 1, so on and so forth. I'm just going to do it real quick for the rest of those, and we'll be done with the example at least. So we do that. So first step is to assign the cells, the spots where the mines are going to be. After that, we need to check every neighbor for every cell that are not mines and assign them a value, right? A value between 1 to 8, which is just going to represent the number of mines surrounding it. There you go. So that's pretty much the concept of how you build the board for Minesweeper. Now we need to basically see whether, so we'll have like, for the moment, let's just think of it as one event. So one of the event will be whenever you press on the board, right? Whenever the mouse is pressed on the board, find out which spot you pressed on, and afterwards look at if it's a tile or if it's a mine. If it's a tile, just reveal it. If it's a tile 0, reveal itself and all surrounding 0 and above neighbor, right? So that's the plan. So I was thinking of having like a game object, maybe like a Minesweeper object. So some kind of Minesweeper object. So this should contain the board. In the board, I was thinking of setting it to like a 2D array. In our case, it'll be 8 by 8. What else? It needs maybe the revealed cells, or we could contain that. Yeah, we could have the revealed. So let's set that, right? Revealed. So revealed would just be an array of object x, y. The board should contain either like one index over here, like I'll just put an equal, but basically one spot in the board should be either I'm thinking of like a value, a number value, right? So we would have, let's say, 0 through 8 for the tiles, and then maybe -1 for the mines. Yeah, I think that's fine. So the mines would be -1, and the rest, the tiles, would just be their number, right? 0 through 8. Revealed would just be the location, the index for the x and the index for the y. What else? We could have the mines in here. Mines equals, it would be basically the same thing. So an array with x and y. Well, I guess we don't need that, right? Since we'll have that. We can have maybe a function to get the mines. It would just go through the board and return you all of the board cells with -1 is the value. What else do we need? We'll eventually have like a on click event or some type of event that will be triggered whenever we click one of the cells. What else? I think that's pretty much it. Well, eventually we can add like the end condition and whatnot, but for the main part of it, this is the core game mechanics, right? So let's get cooking. All right. So I have this file Minesweeper. I'll create a function class. I'm fine with that. I could just create a class, but it doesn't really matter. So the class will be Minesweeper. Well, whatever, the function will be Minesweeper. We can store as well the size of the board in here. So I'll have a function. Let me zoom in a little bit. Maybe this is better. For initializing, that's good. So we will initialize this, the board equals this. Let's also set the game. Maybe we can pass the game. Maybe we could pass the difficulty. Does that make sense? Yeah, I guess so. Difficulty. All right. So difficulty, and we'll say by default it's beginner. Beginner. Okay. So we'll say let call, let row, and we can just have either switch or an if, else if, so on and so forth, right? So calls would be equal to 8. rows would be equal to 8 in this case. Let's also do let mine count. Okay, mine count in this case is 10. Okay, so that's for difficulty beginner. Else if difficulty not beginner, but I think it's intermediate. Intermediate. I think it's written like this. Anyway, it's 16 by 16, so double the size. 16 by 16, I said, and the amount of mines is, I think, 40. Let's go with that. And last one is expert. All right, so it's, let me check. Expert is 16 by 30 with 99 mines. So, and number of columns will be 16 by 30 with a mine count of 99. There you go. Okay, awesome. So now we just create the board. Well, let's create the board after setting those variables. Okay, and let's do a loop for that row. It's fine. Going to be the I don't want the row. I want the columns. Let's do call. Here it'll be calls and call. Okay, that's good. Okay, so for let rows. Okay, that's all good. All fine and dandy. So this is the board.call equals another array. That's fine. And this one will all initialize them. We can all set them to null by default. There shouldn't be any null values at the end of this. But we can set that like this for the beginning, like just for right now. We'll update it, right? So now let's also set like const available spots. So I'm going to push into this array the dot push the x and y, or the calls and rows. I don't really like calls and row. Well, it's fine. So I'll put in here call and row. All right. So what's the issue with available spots? Okay, that doesn't matter. Okay, so now we need to go through all of the amount of mines that we have. So int I equals 0, I is less than mine count, I plus plus, awesome. Let's go here. Let's say there's the available spot. We can randomly select any of those spots, right? You could use mat.random and select a random index, a random value between 0 and the available spot.length and get the floor of that. That would give you an index, but I'll just use the p5 function random, which you can pass an array to it and it will return you just one element of that array. Right, so const call and row. Okay, great. And now we want to set this the board dot call and row equals to -1, right? And we want to remove that index from this. Well, okay, so I'll need the index, right? Const index equals, so like I said, it's going to be random, and we'll need to floor that value. So random between 0 and the available spots dot length. Okay, so now we've got the index. Now I need to, instead of doing this, I need to use splice, which will remove elements from the available spots array and return them. I believe it returns them as arrays, so I'll need to do this. Let me check the doc real quick. Returns an array, right? An array, so that's good. So here, this is the index value, and then how many elements we want to delete. In our case, it's only one element that we want to remove. So that's all good, and we need the first index, so that's good. I think I'll even destructure it here. I believe I should be able to do this. Okay, great. So now we've set the mines. Okay, great. Now we need to check all of the spots in the board and set their value. So let's just have a first condition, making sure that it's not mine. So if this equals -1, then continue, right? Because we don't want anything after this to be executed if it is a mine. We don't need to set it. So what we'll do is we'll check all of the surrounding neighbors around it and count them. So we'll do sure, we'll do let neighbor count neighboring mines. Neighboring mines by default is going to be equal to 0, and then what we can do is just do let's do let me think. So we'll do if this is going to be repetitive, there's most probably a way to do it in a for loop, which I think we could do. I think it's not really a long thing to do. Sure, I'll update the okay, so this will be let's say call2. Well, let's select x and y. We haven't used them yet, so why not? X. So here, this is going to be call +1, and here this is going to be call -1. X++, that's fine, and then for let y equals to row -1, as long as y is less than row +1, y++. Okay, great. So now we can just say if x is greater than, give me a second, I'll be right back. Sorry, I needed to go check something out in the house. Okay, all right. So, like we said, x is, as long as x is greater than 0, or we can say like, we can continue. Okay, so if x is smaller than 0, or x is greater than calls, right? Yeah, calls dot length. Well, just calls -1, right? Or if y is smaller than 0, or if y is greater than rows -1. I think. Continue. Right? I think so. What's it? Okay. So now we just need to add 2 neighboring mines. If this dot board index x, index y, is equal to -1. Then we add to the neighboring minors. Okay, I think we're good now. Okay, so now we need to do, just need basically to set this value to this. I think so. I think that's it. Equal to neighboring mines. Awesome. Okay, so I think we're good with the initialization. I believe so. Let's see. All good. Okay, so let's at least draw the board on the screen with the numbers in it, right? Whoa, that's a bit too big. Okay, so let's set like let Minesweeper. Let's set the full name. It's fine. Minesweeper equals new Minesweeper. I don't need to pass it the canvas. Okay, awesome. So, and we can initialize it right away, right? Okay. Okay, there is an error already. Let me zoom this in. That's fine. Okay, so on cotton promise, cannot set property of undefined, setting 0. Okay, interesting. Minesweeper 28. Minesweeper 28. Let's take a look. Minesweeper 28. Over here. Oh, right. Call, and this would be row. Okay, there you go. No more errors. That's good. Okay, great. Wasn't a big deal. Let's draw the board now. So let's set the scale of the game, like of the cells, of the spots. So const SCL, because I believe scale is a reserved function for p5, so let's not mess with that variable name. Let's say maybe 20 is fine. Who knows? So SCL. So in the draw loop, I could do this outside of the draw loop as well, but it doesn't really matter. I don't want a dark background. Let's just do white. Sure. Okay. So so let's just create a constant for the board, just because I don't want to call like minesweeper.board every time. Minesweeper.board. And let's do for let x or let call equals 0. Call is less than this dot length. Call plus plus. Okay, great. We need to do the same for the row. This will be board index call dot length row. Okay, great. So now let's get the x, which should just be the scale times the call, and const y should be the scale times the row. Okay, and the dimension should just be the scale, right? Okay, let's try it out. So let's do rect. I'm going to do no fill, and stroke a black stroke, just so we can see it better. So x, y, and scale. Awesome. So we already have our board drawn out. Let's maybe put a bigger scale, maybe 50. Okay, that's fine. Let's do maybe stroke weight of like 2. Okay, now we can see it. We can maybe move it a little bit off the edge, but for right now, we'll leave it on the edge. It doesn't really matter. And let's do this even a little bit bigger, maybe 70. Sure, that's good. All right, so now let me draw as well the text. So let's do text. Let's do fill fill black, sorry. Let's do no stroke. No stroke. Text size, maybe 20. Text line, maybe center. Oh, center. So X is going to be X, Y is going to be Y, and the text should just be the board, index call, index row, right? Okay, plus SCL divided by 2, good, plus SCL divided by 2, good. So we see our mines, we see our numbers, we're pretty much good to go. Let me do something like filling the value, filling the rectangles with some kind of red. So let's do fill. If this equals -1, then let's do tomato color. Otherwise, let's just do white. So we can see our mines right here. And I'm currently seeing an issue, a pretty major issue from what I'm looking at right now, where, as you can see, there is zeros around mines. So our numbers doesn't add up, right? So we've done it the wrong way, it seems, right? Over here, there's 2, but there's actually 3. Over here, there's 3, but there's actually 4. What is the issue exactly? If x is smaller than 0, okay. If x is greater than cols -1, sure. If y is smaller than 0, if y is greater than rows -1, continue, okay. If this does board index xy equals -1, that makes sense. Then neighboring mines plus plus. Okay, that seems to make sense to me though. Seems to make sense to me. What would be the issue? Um, So neighboring mines plus plus. That makes sense. Rows. Sure, that's. Oh, you see this here? This should be col. This should be row. I shouldn't just accept whatever it's giving me, right? Okay, now the board is totally wrong because over here as well, it's badly done. It's definitely my fault. Let's search, why not, XY here as well. There we go. Okay, so let's take a look. Here there is 4, but why is it only saying it 2? Let me search for this, but the other way around, right? There's none. Okay. Our issue is most probably in here. Well, it's definitely in here because the -1s are fine, and it's really the rest that is not. Probably missing something like in my face. X is smaller than 0 or X. This can be moved. Let's minimize what we have. So if this, continue. And then let's do for the Y. This is not right. This is totally wrong. It just doesn't make sense. Is this inside the right loop? It seems like it is. Calls -1. Yeah. I mean, yes. I'll check what's the issue here and come back right away. I won't be long. All right, so I've got the issue figured out. It wasn't a big thing. It was just smaller or equal, right? Because we want to go to the index call +1 and to the index row +1, not up to but not including that index, right? I've just helped myself with some debugging console logs, and there you go. Okay, right? So now if we take a look at it. So for example here, right? 3, 2, 2, it makes sense. Here 2, it makes sense. 2, 2, it also makes sense. This looks good right now. So we're all good. So what else? We can have a variable called revealed, right? Revealed would just be, like we said, I believe, yeah, revealed would just be an array of index, right? So column, row, right? So we'll have this dot revealed, right? Revealed, is it written like this? I think it is. Anyway, revealed will just be an empty array to begin with. And then I'm just going to, instead of this over here, all of this, I really don't need it. Well, not all of that. What we can do instead is just do for const call row equal of minesweeper dot revealed. Do all of this for parentheses const. Okay, there we go. So now we should be good. Though we should still draw the board. Yeah, let me copy this, but let me go back as well, because I'll still be drawing the board initially, but not the numbers and not anything, right? Well, this, yeah, for the moment, let's keep it, but we'll remove it in soon. Okay, so let me remove this. Let me add this in. Okay, awesome. So now we're drawing the board, but not drawing the actual value of each cell in the board. We'll only draw the ones that are revealed. So let's create a function that reveals a cell, right? So we'll have minesweeper dot prototype dot reveal equals a function. This function, I think it should receive the call and the row that it wants to reveal. So if call row equal -1 failed, or yeah, failed the game, or lose the game. Awesome. Okay, So, and we can do like early return. Just for the moment. Like eventually you'll want this to be something, but right now let's just handle like the valid conditions. So if this the board equals 0, we want to equals 0, not rows calls. I want calls row. It doesn't. Yeah, I mean LLM doesn't, like, machine learning doesn't understand what I want, which is fine because I don't need it. We can just do it, right? So whenever it's 0, we want to reveal all of the surrounding neighbors. So we can just call reveal on itself, right? So we'll need to basically do this for each neighbor, right? Yeah, that's fine as well. Okay, and we'll do we'll call this dot reveal with x comma y. That's good. And before doing that, we will just reveal ourselves. We can say as well, we can say if it's already revealed, just don't do anything. So we can do if this dot revealed dot find index. Let's call it. Let's call it R or spot, and we can say something like x here. Const is revealed. Okay. So we'll just check that our call equals spot.call and our row equals spot.row, right? Yeah. And if this is equals to -1, then we know it is revealed. So if it is revealed, we can just early return, doesn't do anything, doesn't change any state of the game. So that's all good and dandy. So here, in the case that we do reveal the neighbors, we will just set a push to the revealed array current call and row. Okay, great. I think we're pretty much done with the reveal function. Well, if it is not, we can just do this, right? Because if it's not 0, we want to reveal it anyway. The only thing is when it's 0, we want to also reveal its neighbors. I think we're good. So let me use here a function called mouse pressed. And then we can just figure out the call and the row, which will be the call will be the floor of the mouse x divided by the scale, and the y, well, not the y, but the row should be exactly the same, but for the y. Great. And then we can say like if I mean, I would just make sure in the revealed over here if, and maybe I want to set this as sure, let's do that. So copy this, so we'll just paste it here. We'll do copy again, this dot equals this. Okay, awesome. And here we can just say if call is greater than or equal to this dot calls, right? Yeah. Yeah. Or calls is smaller than 0, or row is greater than or equal to this dot rows, or row is smaller than 0. We can just return early again because it's not in our board, so we don't really care. Okay, so we can call Minesweeper now dot reveal with the call and the row. So now let's click on any of these. Okay, so I clicked on it. Did something happen or not, right? We don't really know, actually, at the moment, it seems. What reason? I'm not sure. Let's just console log, make sure that it gets in here. Whoa, olog, that could be a nice name. Function, let me just... Okay, so mouse pressed is getting called. So that's good. Is revealed getting called now. Let's do... Let's pass in call and row. Let's see now. 410. I mean, it's a 10 by 10 grid, so it should be... No, it's 8 by 8, sorry. Okay, so 6-2, right? Should find something in here. But it didn't. Let me see where we get. Do I get over here? I do? Okay, what's the issue? This is most probably the issue at the current time. You know what? It needs not to be equal to -1. Ah, there you go. There we go, there we go. So now clicking outside doesn't do anything. Now if I click in here, it should not, well, let's click on one that is not 0. This one, for example. Okay, so it revealed a 2. That's good. Now let's click on this one, which is 0 at the moment, right? It should reveal all of its neighbor, and its neighbors should reveal the other one. But there is an issue. That makes sense, right? So calls. Where is that issue? Minesweeper line 84. 84 over here. Okay, I get it now. Okay, and it'll be this dot rows. Okay, now let's click here. Should reveal all of the surrounding ones. Yes, it did. Great. Now over here. Awesome. Okay, so we're pretty much done with the mechanics of the game. All we need to do now is whenever we, like the lose condition, now we need to do, like, what happens when you do lose. We could reveal the full board, I guess. That could be nice. Sure, let's do that. Why not? So let's do like this dot reveal all. So we'll need a function for this. Sure. Sure. Why not? So we'll just need to, well, let me copy the loop I've already done multiple times. Well, at least once here. You paste that in. I don't need this. I don't need this. I don't need this either. Let's do this dot reveal call row, and we will also be setting this in here instead of down there. Okay, let me click on one. Okay, there's an issue. That's good. Calls is not defined. Yes, I know. This dot, man. I always forget it. Okay, good. So now if I click on any red cell currently, it should reveal everything. It did. Great. So I'm thinking whenever it's the end of the game, we just show everything to the person playing, and they can be like, oh, shoot, the bomb was there. Oh no, the bomb was there. Oh no, okay, so on and so forth, right? You get it. Okay. Cool. Well, I think that's pretty much the game. One thing that could be nice is maybe centering the numbers. Currently, they're a little bit higher up than I'd like. So let's maybe reduce that by maybe by 10, right? I just want to see. Oh no, add 10 to it. That seems center enough for me. That's good. Let's maybe do text size 20. Instead of no stroke, let's do a stroke black. Let's do stroke weight of like 3, something like this, right? Should take. Okay, that's cool by me. Alright, so this is pretty much the Minesweeper game, right? So the only thing would be that there wouldn't be anything in here. And what we could do actually is maybe... I'm fine with this, but here the fill should be white. Okay, right? So the only other thing I would like is whenever we do reveal the first cell, it reinitializes itself whenever we didn't click on a whenever we don't click on 0, right? So one thing would be this dot moves, or oh well, I mean I can just use the revealed, right? This dot revealed dot line 0. I know it's the first revealing we're doing, right? So one thing first is here, right? If this dot revealed dot length is equal to 0 and over here, so this dot born index call index row is not equal to 0, then I'll just do this dot init, and I'll call this dot reveal with the same call and row, and I'll return here. Sure, I think that's fine. Let me see. I should be able to click anywhere right now and it should pop up like a 0. It's good. It's good. So now the other thing we could do is like on mouse right click, we could flag some of the cells, right? So we could have like a flagged over here. We could have revealed, and we could have this dot flagged equals also an array. I'm fine with that. And we could say in here mouse pressed. I'm not sure if we can p5. Let me look at the references. Mouse pressed. Let me search for just mouse. Mouse wheel, mouse pressed, mouse move, mouse clicked. Let me look at mouse pressed. Mouse pressed, code run here, mouse X, something 50. The mouse system variables such as mouse X and mouse Y will be updated with their most recent value when mouse pressed is called by p5.js. Okay, that's fine. The parameter event is optional mouse press. It is always passed a mouse event object with properties that describe the mouse pressed event. We could take a look actually at this mouse event object because it's probably in here, right? Which mouse? GS how to know which mouse button is pressed. Let's take a look. Check if mouse button down. No. Detect left mouse button press. That's good. That's what I want. Okay, so I ate this mess with the mouse button created by W3C and MSI. No, MS. I want to know if the left mouse button is pressed when I get the mouse down event. Such, I use this code. Event.button. That's interesting. Okay. I.e., we won't be supporting Internet Explorer, I'm telling you. So it'll be event.button. However, it does not work in Opera and Chrome because it so happened that window event exists there too. Interesting. Okay. I mean, it's called buttons? Wait, what? Let us see, right? The button number that was pressed, if applicable, when the mouse event was fired. The buttons being passed, if any, when the mouse event was fired. What's the difference? Let's take a look at button, right? I don't know what both of those do, so don't ask me. We'll see. So we have event here, and we can console.log event.button, and we can do the same for buttons, right? Okay, let's take a look. So if I click right click, sorry. So it's 2 and left click, I get 0 and I get 1. Interesting. So I get 2 both from them, right? So I'll take button. I guess it's fine. Why not? Sure, because probably the mouse wheel is, so it's 1 for this one and 4 for the other one. This is 8, this is 16. This is not button. Okay, interesting. Anyway, oh, is this a button? No, it's not. Okay. I'll just use the button and I'll know in both cases, regardless which one you use, it's going to be so zoo if then the button equals 2, then we'll be calling flag. Sure. Otherwise it'll be reveal. Right? So it'll be pretty much the same exact thing, but it'll be flag. So now we'll just need to do something about flag, right? So okay, awesome. So what do we want to do? Well, this for sure. This also for sure. And then in here, I'll do the same, but for is flag. sure. Because if it's currently flagged, I don't want to reveal it. I'll wait for the user to unflag it for me to reveal it. Well, you could do both, I guess. Both should be fine. Like you could do like either, as long as you let the user know, or you go by the exact rule. I don't know them exactly, but I'm going to say like maybe you were to press the right button, but you pressed accidentally the left button on like a flag mine. Shouldn't do anything. So though, one thing first is I'll say if it is flagged though, you need to unflag it basically. Is flag, or we can get flag index. There. If flag index is not equal to -1, then we basically need to remove it from that list, right? Flagged dot splice, but we don't need the return value for this, so okay, flag index. Okay. Else, you basically just need to flag it. That's pretty much it. So flagged, passing in dot push, passing in call row. Okay, and one thing I want to do is maybe in here, right? We can say, we could say get, I'll just do this. Or I can just, yeah, I'll just do that. I'll just do another loop, but through the flagged ones. So instead of this, it'll be flagged. All right, and we will basically do this. Whoa, do this. But in here, the color should just be some kind of yellow. Yellow. Cool. All right. So if I click anywhere right now, okay, that's good. If I flag this one, I need to disable this as well. Prevent default. I think that should do it, right? No. Okay. How to prevent context menu.